Okay, let's, now that we've defined radians, looked at how to convert from degrees to radians, and from radians to degrees, let's look at how we sketch angles. So if we're given an angle and we want to represent it graphically, what does that mean? Well, let's look at some examples. First of all, I'll start up here in the upper left, and I want to sketch pi over 4. So if you're asked, you're given an angle and say, okay, sketch this. Well, one thing you know is that pi over 4 is 1/4 of the way around half of a circle. So if you divide that half a circle into 4 equal parts, 1/4 of it is where you're going. So 1/4 pi over 4 would be represented that way. This is the theta. Okay? So here's what we note about this. One, these angles are formed by the initial side and the terminal side, rotating counterclockwise. Notice this positive angle, pi over 4. We rotate from the initial side in a counterclockwise fashion until we go 1/4 of the way around half of a circle, which, remember, that corresponds to 45 degrees.
So when it's negative, you go the opposite?
That's right. When it's negative, notice negative pi over 4. There we rotate in the clockwise direction. So that's going to be our angle beta. So negative pi over 4, when you see the negative angle, that tells you which direction to go. It tells you to go clockwise. Counterclockwise is positive angles. Now when you're talking about radians, you're kind of in the mode of thinking about fractions of half of a circle. That's the way I think about it. So if you look at alpha, where do you think this terminal side of this angle would end up? It's 5/6 of pi. So where is 5/6? Well, 5/6, think about it. 6/6 is all the way around to pi, isn't it? 6 pi over 6, that's pi. So 6/6 would be somewhere over here, wouldn't it? So this angle is right there. This is alpha. It's 5/6 of the way around half of a circle. 5 pi over 6. You can think of it this way. You got 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. Okay? So 5/6 pi is 5/6 the way around half of a circle. Any questions about that? Now let's look at 7 pi over 6. Okay? Think about it. 6 pi over 6 is right here, right? That's one whole, but then you have 1/6 left over, right? So here's 6 pi over 6, 7 pi over 6. About right there. So it would go around like this, and there's your beta. And that's approximate, just to give you an idea about where it is. Any questions about that? Okay, now, what about 13 pi over 6?
It's the opposite of 7, like the fourth.
Well, look at this. Think about 13 pi over 6. What is 6 pi over 6? That's pi, right? Okay, what about 12 pi over 6? That'd be 2 of them, right? Okay, look. We are right now at 12 pi over 6. To go to 13 pi over 6, what do we need to do? You go up another 1/6, right? Now, notice what we did there. We went 6 pi over 6, 12 pi over 6. There's one more 1/6, up one. Now look, here's the way I do it. I take the 13 divided by 6 and get the quotient. Well, 13 divided by 6 is 2 for quotient. Now the remainder tells you how many half circles you go through. 13 divided by 6 has a quotient of 2. So you go 1, 2, and then the remainder tells you how many sixths of another, what fraction of another half circle you go through. See that? So look at this. 22 divided by 3, what is that?
Go
the quotient is 7. So look, we go 1, 2, 3, 4, 5, 6, 7. What's the remainder? 1. So you go 1/3 of the way around to the next one. And there it is.
So we need to draw those little.
Yes, ma'am. If you're asked to sketch if you're asked to sketch an angle, you indicate how many. You indicate that it goes several times around by those little curves. Now let's look at negative 15 pi over 4. Now we know right away we're going to be going clockwise. So look, what's 15 divided by 4, quotient-wise? 3, right? Because 4 times 3 is 12. So look at this. We go 1, 2, 3. Now there's a remainder of 3, isn't there? So we go 3/4 of the way around. 3/4 is going to be over here. And there it is. Does everybody see that?
So we need to, like, if we're given the degrees, do we need to find their radians?
No, ma'am. If you're given degrees, you can go ahead and sketch in degrees too. Like if you were asked to sketch 45 degrees, same way. Like it would look exactly like this. Okay? Any questions about that?